Hello, my name is Suyong Bae, and I'm going to present my recent accepted paper named DeCAP, a context-adapted prompt generation for devising zero-shot question answering in large language models. This paper is accepted at NAACL 2025, and I'm going to present my paper at New Mexico in USA on May. And I'm studying at Information and Intelligence System Laboratory, and my advisor is Professor Jiyoung Lee. And in our lab, various types of research are being conducted, including computer vision, natural language processing, multimodal, and lightweight AI. And to introduce myself, I am now a PhD student, and my research topic is mitigating bias and hallucinations in large language models, and trustworthiness in long and complex summarization tasks using LLMs. And my presentations today is following as this content. So, my paper named DeCAP aims to address the bias in large language models. Bias has been identified as a critical issue in LLMs. In situations where the LLMs answer user questions, the propagation of the LLM's internal biased knowledge into the answers is a significant problem. For example, when user asks following sensitive questions like, an Asian woman was taking classes with a Caucasian woman who was a bad driver. In this case, there is no exact context about who was a bad driver in the question. Therefore, the LLM tends to determine between two women based on their internal knowledge. So, if the LLM has a racial stereotype, the answer might be that the Asian woman was a bad driver. So, the main reason why the LLM manifests the social bias is that since LLMs are trained on a large amount of web scraping data, they are likely to reflect and amplify social biases. And recent studies have highlighted that LLMs trained on unfiltered web data can generate biased responses related to gender, race, and sexual orientations. To address these issues, various methods have been proposed. One common method is the retraining, which involves identifying and removing or balancing biased data during the training phase and retraining the model. And another approach involves modifying the probabilities of masked or next tokens to output neutral or less biased tokens. However, this method consumes significant resources and GPU power during the training process. Therefore, recent research's efforts have focused on proposing zero-shot method without additional training. So one method to reduce LLM bias in question answering tasks without additional training is to directly add information related to bias or debiasing instructions. This approach is effective in improving performance and devising ambiguous questions where information is insufficient. And another method involves asking the LLM to explain potential biases in the question and then using the generated explanations as a prompt. However, the two previous zero-shot methods also exhibit performance limitations when applied to general question answering models. This is because existing methods do not consider context. The question context can generally be categorized into ambiguous and unambiguous. First, in some cases, the question is ambiguous, making it impossible to infer a clear answer. And in other cases, there is a clear content to answer the question. Therefore, for sensitive questions, when the context is ambiguous, the model should avoid biased judgments and respond with "I don't know" or "unknown." However, when the context is unambiguous, the model should provide an accurate answer based solely on the given context. So, a truly debiased LLM should be able to distinguish between these cases and respond accordingly. However, since the previous method applies same prompt without considering the question context, therefore a performance trade-off occurs between ambiguous and unambiguous cases. From the perspective of question answering accuracy, when applying existing zero-shot prompting methods for ambiguous questions, performance significantly improves. However, for unambiguous questions, the model's ability to provide accurate answers actually declines. And when measuring bias levels, the bias is significantly mitigated for ambiguous questions. However, the bias slightly worsened for unambiguous questions. So therefore, to address these trade-off gaps, we propose a new method of DeCAP, which is context-adapted prompt generations for devising zero-shot question answering in large language models. Our method enables the LLM to consider the context and minimize the propagation of bias from internal knowledge into the generated answers. So, our method contribution is three things. First, we can detect the context ambiguity and we can apply context-aware prompting for devising question answering tasks, and our methods do not require any additional training. From now on, I'm going to explain about our method. DeCAP consists of two main processes: A. Question ambiguity detection, and B. Neutral answer guidance generation. And A. Question ambiguity detection selects a prefix instruction to provide clear instructions tailored to each question type. And B. Neutral answer guidance generation generates a neutral answer guidance to guide the LLM towards debiased answers by ensuring the LLM fairly considers the question. And the sentences gathered through processes A and B are added to each position on the context-adapted prompt. So firstly, we design a question ambiguity detector to classify the type of questions based on their level of ambiguity and select an appropriate prefix instruction. This approach enhances the LLM's ability to respond adaptively based on the question's context. So, distinguishing the ambiguity of an input question is a challenging task. Therefore, we propose a simple and efficient method that utilizes the extent to which the LLM's reasoning for a given question reflects the input context. We hypothesize that if the context of the question is ambiguous, there will be insufficient information to answer the question, resulting in a lower similarity between the generated answer and the context. Conversely, if the question is unambiguous, the similarity will be higher. Based on these assumptions, The first step is to provide the context and question to the LLM, prompting it to answer the question with the reason. During the process of generating a reason for a question, the LLM will present a convincing reason supporting the question. And to quantify this similarity, we calculate the load score between the context and the answer combined with the question. So, through the load score, we can calculate the score between 0 to 1 of how the contents between context and reason are similar. So, we choose the threshold through our pilot experiment. So, based on our defined threshold, if the score is lower than our threshold, the question is classified as ambiguous. And if the question is higher, the question is classified as unambiguous. So the prefix instruction is predefined based on the question type. So we define the prefix for ambiguous and unambiguous questions as follows. Our detector can ensure consistent performance across different types rather than relying on the LLM's internal knowledge. To verify this, we compare our load-based score with two other LLM-based detectors. The LLM is designed to distinguish between ambiguous and unambiguous cases by inputting a prompt like the one shown on the left. And our results table is displayed on the right. As we shown in the table, while two LLMs perform well in classifying ambiguous questions, their performance in classifying unambiguous questions is significantly lower than that of our method, showing a substantial gap between the two question types. Second, neutral answer guidance generation is designed to provide the model with additional neutral context related guidance and prevent from relying on its internal biased knowledge. To create this guidance sentence, we retrieve external knowledge that is socially acceptable and unbiased, constructing few-shot demonstrations that enables the guidance generator to produce neutral information. First, we retrieve the external data that is neutral and unbiased to provide fair and unbiased responses to sensitive questions. Therefore, we use square dataset, a large-scale dataset consisting of two types of sentences, like sensitive question and acceptable response. For example, a sentence question might be, should we refrain from making discriminatory remarks about a particular race or ethnicity? And an acceptable response might be, no groups can be said to be superior or inferior compared to others. This dataset, generated through human-machine interaction, is widely used for research aimed at providing fair and unbiased responses to sensitive questions. So, since our goal is to generate a neutral answer guidance sentence related to the context, we retrieve similar entries from the square based on the embedding similarities of the given question, using them as demonstrations to help the guidance generator produce high-quality sentences. Therefore, first, we embed the question, including context, and the Q and R pairs from the square into a representation space using a pre-trained sentence embedding model like MPNet. Then we choose the top k similarity pairs as demonstrations. After constructing a k-shot demonstration using the retriever method, we then input this demonstration along with the input question in a few-shot prompt format. The generated neutral sentence can provide the model with additional neutral context, related guidance, and prevent it from relying on its internal biased knowledge. So the final selected prefix instruction and neutral answer guidance for each question are augmented at the beginning and after the context respectively, as shown in the context-adapted prompt. So we evaluate our proposed debiasing method using two bias QA benchmarks named BBQ and Uncover. Both benchmarks follow a multi-class question answering format where one option is selected from multiple choices, and there are annotations for question types like ambiguous and unambiguous. Using these benchmarks, we conduct experiments to assess how effectively our method mitigates bias in question answering models and how well it resolves the problem of performance trade-offs between question types. So first, the BBQ dataset comprises a total of 11 bias categories, and the dataset includes both ambiguous and unambiguous questions, each with 3 options, including an unknown options. And the Uncover dataset only consists of ambiguous questions related to 4 bias categories, and each question includes 2 social group options. So in our experiment, we add an unknown option to the answer choices in the dataset. To validate our method across various LLMs, we use various models publicly available to researchers for our main experiment, and we additionally conduct various types of LLMs from Mistral to GPT. In this study, we mainly use accuracy to measure our performance. For ambiguous questions, the correct answer is always the unknown option, and unambiguous questions, the answer is based on the question's context. And we additionally calculate the bias score. This allows us to observe how biased the model's answers are. So we use the score defined by the paper of BBQ dataset for both question types. And for implementation details, we use the Llama 3 instruct model for reasoning in the question ambiguity detection process and a guidance generator for generating neutral answer guidance. And the threshold for the ambiguity detector is set to 0.35, and for demonstration retriever, we use the top 5 most similar pairs. Now I will explain the experimental results. In both benchmarks, DeCAP achieves the best performance in accuracy. Specifically, accuracy improves by approximately 22.87% over base in the BBQ and by about 50% improvement in the Uncover dataset. Moreover, compared self-devising and prefix instructions baselines, DeCAP shows over 10% improvement. And when analyzed by individual LLM models, DeCAP shows the best performance in all cases except for Llama 2 and Llama 2 Chat 7 billion in the BBQ, where it rank the second best. This indicates that our method demonstrates consistently high performance across a range of LLMs. And in terms of bias mitigation, DeCAP achieves the best performance. Bias is reduced by approximately about 12% compared to base in BBQ and by 2.27% in Vancouver. Furthermore, DeCAP outperforms all baselines. This research shows that DeCAP is an effective approach to mitigating bias that presents to verified degrees depending on the question types. Additionally, experiments conducted on 5 more additional LLMs shows that all of them demonstrate strong performance. And to demonstrate that our DeCAP effectively reduces these gaps by applying context-adapted prompts, we compare the performance gap between ambiguous and unambiguous questions with existing methods. So, applying the existing methods named self-devising definitions improves accuracy for ambiguous questions but decrease it for unambiguous ones, resulting in a performance trade-offs. And in contrast, applying DeCAP significantly reduces the performance trade-off and reduces bias, with much smaller difference between the two question types. So based on this detection performance, the experiment results on the left shows the devised QA performance based on the detection correctness and analyzes how effectively the neutral answer guidance prevents the LLM's internal bias from propagating into the answer, even when the detector incorrectly predicts the question type. So if we look at the blue box, when applying neutral answer guidance, both accuracy and bias reduction improved, even when the question ambiguity detector misclassified the question types. And the right experiments, we evaluate whether the generated neutral answer guidance naturally follows the context and whether it is neutral and unbiased. So for this evaluation, we use ChatGPT instead of human evaluation. So the evaluation results displayed in the table on the right shows that 89.9% of the generated neutral answer guidance are coherent and 75.8% are neutral in the case when the answer is correct. So this result indicates that the neutral answer guidance is both coherent and neutral, contributing to improved performance. And lastly, to evaluate whether our method demonstrates general debiasing performance across bias categories on various LLMs. So we compare and analyze the bias scores of the base model and our DeCAP. So the analyst research showed that bias is generally reduced across all bias categories. So at the end of our presentations, our paper's conclusions are as follows. So we propose novel method of context-adapted prompt generations, which improves the QA performance of LLMs while mitigating bias without additional training. And our main contribution is that our method effectively addresses performance trade-off between ambiguous and unambiguous contexts with mitigating biases. So As the result of our experiment, DeCAP consistently achieves outperformance across various LLMs and proves to be effective across a wide range of bias categories. So this is the end of my presentations. Thank you for listening, and if you have any questions about my papers and my research topics or our labs, feel free to ask questions through my emails. Thank you.